Hi, I'm doing this video to help you write the equation using transformations. Write the equation of a function using transformations. Okay, let's share. So this is the function given. And they say the graph above is a transformation of the function f absolute value of x. Write an equation for the function graphed above. Okay, so this f of x, I always replace with y. It just helps me. That's why that's what I like to think about it. So, remember when you used to do t-tables really fast, like, you used to have you had to pick values for x and then you plug in values for y or f of x. I'm sorry, you pick values for x and then you calculate what the corresponding y value or f of x value are, function value is. Of course, it goes with every x value, right? Okay. So this x is now, we're going to call it our input. It is what we input into the function. And remember a function expression? We have, this is where things are input into our function. And the function itself is going to take the absolute value of whatever you put in it. And then that's like the equation for the function. And then we have the output. Okay. We could write the output like absolute value of x. That's exactly what it's going to do. It's going to take the absolute value of whatever it is, right? Okay, so something is important. When a graph moves up and down, there's a vertical shift. Let me draw the function first. First, we have to remember what the original f of x equals the absolute value of x looks like. We have to have these memorized for all the functions, actually, all the major ones that we're going to learn for this class. This is one of the major ones. F of x, if it equals this absolute value of x, this is what the equation looks like. It's a v and centered at 0, 0, and it's upward facing, okay? And really this comes from the fact that if we replace this with y, and this comes into really kind of two equations, it's y equals x, which is just the straight line, and it goes through 1, 1, 2, 2, 3, 3, it's just a straight line, and y equals negative x. It's those two equations put together. So we have y equals negative x on this side and y equals x, and that's what this graph kind of comes from, okay? All right. But notice how this other one is different. So the first thing that I'm going to notice is that the point here is no longer at, this is like my center point of the absolute value graph. I notice that it's no longer at 0, 0, like the typical simplest function is. I said again, this is a graph of f of x equals absolute value of x. Its center is located at 0, 0. This is not located at 0, 0, so it's an indication to me that it's been moved. Like it used to be here and it's been moved exactly one place to the left and one place up. So let's work on that. Let's work on that individually. For it to be moved one place up, that's a vertical shift. It's a vertical shift. For me to move this graph one place up, I have to take the outputs and add 1, which means after the function takes the absolute value, then I need to add 1. Okay, so the adding of the 1 comes in the output or to the y value or function value. So I know the final equation is going to have a +1 on it. Okay, it's going to be like f of x something +1 because that's why it's shifted up. Okay, and then now I notice not only is it shifted 1 up, but it's also shifted 1 to the left. And how do we shift a function left and right? It's by changing that. You're changing the values on the x-axis. And if I want to change the values on the x-axis, these inputs are your x values. So if we want to change and shift a function to the left or right, we have to do it to the input values because that's what changes the x values. So if I originally am plugging in x to the function, then when I move it 1 to the left, I actually went negative. I went 1 space in the negative x direction, negative horizontal direction, but we do the opposite. We add 1. So we actually have to add 1 to the input. So if I add 1, this becomes x plus 1. So in parentheses, I do x plus 1. Okay, but we're not quite done yet. Okay, so now I took care of the fact that we moved 1 over and 1 up by adding the 1 onto the input and adding the 1 on to the output. But now this is actually the graph if I graphed it. It would look like this. That's currently what we have. How can I make it flip about the x-axis like that? How can I make it flip upside down? And we have to think about this, but you're basically going to be taking every y value, right? Taking the y value here, which is 3, and making it and flipping it and putting it down here. So you're actually going to take the outputs and make them negative. So it's going to be a negative x plus 1. And now we kind of have to think about this, and you may even want to like just try to do a few problems just to make sure that this is the correct expression. Because I'm kind of curious, do I have to make this also a negative one? Because this is the whole function right now is negative but do I have to make this negative one as well? I don't think so, but it does not look like it. But we can double check this and by kind of plugging in a value, like let's plug in. So we know this point, which is -1, 1 is actually on the graph. So when I plug in a -1, I should get a +1 back. So I plug in -1. So -1 plus +1 is going to be 0, but it's the absolute value of 0, which is just 0, and then they made it negative, which doesn't make any sense, but then they add 1, so we do get +1. When I plug in -1 into this function, I do get +1 back. So that is a good indicator that probably this might be the right equation for this. It's good to kind of double check yourself. We can double check a few more points, right? I know this is a point on my graph, right? So 0, and this doesn't always work because it looks like it goes through 0, 3, or I'm saying -3, 0, but actually the graph might not actually, it might be go through like -3.01, right? So it may not exactly go through this, but we should still expect it. If I plug in -3 into the function, I should expect values close to 0 at least. So if we get -3 plus 1, and -3 plus 1 is -2. Take the absolute value of -2, it's +2, and then we make it negative because the negative sign out here. And then I get +1, which is not the answer that I wanted to get. Yeah, that is not the answer that I wanted to get. I wanted to get, when I plug in -3, I get 0. Okay. Oops, I did make an error here. -2 plus +1 is -1. So that's silly. But something else that I did not mention here is with this problem is there's also something else called your stretch. This equation kind of looks, the lines look steeper. Actually, the slopes are different than you see here. So actually, there's more going on here than first meets the eye. So sometimes when you're just beginning these transformation problems, all they do is kind of just pick up the original graph and kind of shift it up and over and stuff like that. They do simple transformations. Then when you get more, then what they might do is they might do more complicated ones. And in these ones, they're going to multiply, or they call it a stretch or a compression of the same formula. So that's what's been happening here. Like look at this graph. The slope here is, I go down and I go 2 over to get, and notice, so it's a slope of -1/2 on these lines, and the same thing on the other side, I believe, as well. Or actually the other one is +1/2, but like it's over 2 and up 1, so +1/2. So actually the slope of these lines is different than the slope of these lines over here, because this is 1 over 1 up. So this is the slope of 1. So that means that there's a number in here, in front here, that a compression number that has affected this function as well. And that's why I plugged in the value and was like, hey, I'm not getting that value back. And one way of finding that number, it's kind of a complicated process to kind of do, but we can just let that number be A. Okay, and one way of finding this A, this stretch factor, so it's probably, I'm guessing that it looks like this. That's what the equation looks like. There's some value right here that we don't know what it is yet. And the way we can do this is we can plug a value in for f of x, and that known value that we know is on the line, and plug in a value for the x. So we're plugging in basically an ordered pair, and we're gonna, there should be only one unknown. It's gonna be the A. So that'll help us figure out what the A should be. So for example, I'm gonna plug in this point that looks like it's on the line. Let's do this point right here. It looks like it's right, it looks like this point, 0, what is that? 1, 0, it lies right on our graph, right? So this, if I plug in this this function value and this x value, it should make the equation balanced and true, and it should tell us what this A should be. So I plug in 1 for x, and I'm not going to make the A negative. I think that's just going to confuse me. I'm going to make it a value, and then whatever it I'm sure it's going to be negative. It'll resolve itself. If it was supposed to be negative, then when we solve for A, it'll be negative right now. If it was supposed to be positive, then it'll be positive, but we don't want to, it's going to be confusing for us. Okay, so in for X, I put 1. And in for f of X, I'm going to put 0. Okay, so then I subtract 1 from both sides. And then I get -1 is equal to A, and then in absolute value, I get 1 plus 1 is 2. And then now I divide by 2 on, well, the absolute value of 2 is just 2. So it's 2A is equal to -1. And then I divide by 2 on both sides, and then I get A is equal to -1/2. Which is exactly what I was telling you before, that the equation of that line, the slope here has an equation of -1/2. So that kind of makes that's what I expected it to be. So our A here is -1/2. So the actual equation that we want for our answer is -1/2 absolute value of X plus 1 plus 1. So, and then if we wanted to just double check it to make sure, we could also plug in another value that we know should be in it, like on the graph, like we could plug in this crucial point 1, -1, 1. So if I plug in, well, let's try this one before that did not work for us. This point is -3, 0. Let's make sure when I plug in that when I plug -3 in for X, I do get 0. So let's see what happens. I plug -3 in. And let's see what the G of X is. Okay, so I add those together, and then I get, that's -2. When I do the absolute value of -2, I get +2, but then times by a -1/2. That gives me -1, right? Because these are going to cross cancel, and I just get -1 plus 1, which equals 0, which is exactly what I wanted to get. So when I plug in -3, I should get the function value of 0. If you wanted, you could check just one more point, like just this point. We check quickly just to make sure that this does appear to look like the correct equation. And it's very unlikely that it would make all of these points happy. So this is -1, +1. So if I plug in -1, then I would get 0 in absolute value times by -1/2, but 0 in absolute value is just 0, and then times by -1/2 is just 0, then plus 1, so I would get 1. So when I plug in -1, I do get 1. So I am getting, it does look like these points are on this equation, on the graph of the graph of this equation. Those points that we're showing on our graph would be on that graph as well. So it does look like they're the same graphs. All right, and like I just double check my answer. Yes, that's exactly right. That is the answer we wanted. All right, I hope you found this very valuable, and have a great day. Bye.